Alright, so we're going to take a look at the physics questions from this paper of combined and coordinated science. So we're going to start off looking at some mechanics by the looks of it. So we've got an aircraft with mass 3.6 times 10 to the 5 kilograms, and it's moving with constant acceleration from rest along an airport runway. So after 30 seconds, the aircraft reaches a speed of 60 meters per second. Calculate the kinetic energy of the aircraft when traveling at 60 meters per second. So what we're going to use is the formula for kinetic energy, which is equal to half mv squared. So we know the mass, we know the speed at which we can square, which gives us a kinetic energy of 6.5 times 10 to the 8 joules. Okay. So what we're going to do next is calculate the acceleration of the aircraft during the first 30 seconds. So from the previous question, we know its starting speed 0, we know its final speed 60, and we now know the time. So the equation we're going to use is acceleration is change in speed over the time taken, assuming acceleration is constant. So that's what we do, and we get an acceleration of 2 meters per second squared. So just after taking off, the aircraft continues to accelerate as it gains height. State the two forms of energy gained by the aircraft during this time. So the first one will be gravitational potential energy, because we can see that it's gaining height. And the other one is going to be kinetic energy, because it says it's accelerating. So state the difference between the terms speed and velocity. So speed only has size. Maybe it's traveling at, I don't know, 20 miles an hour or 10 meters per second, whereas velocity has both magnitude and direction. So it might be 10 meters per second east, or 20 meters per second at 20 degrees to something. It always comes with a direction. So the aircraft has 20 tires. Each tire has an area of 0.06 meters squared. The weight is 3.6 million newtons. Calculate the pressure exerted by the aircraft. So the equation we're going to need is pressure is force divided by area. So the force, in this case, is going to be the weight force. The area is going to be the total area of all 20 tires, which is why we've 0.06 times 20, giving us a total pressure of 6.0 times 10 to the 6 pascals, or 6 megapascals, if you want to give it like that, where Pascal is the same as a Newton per meter squared. Okay, so it's been raining and there's a large puddle of water on the runway. State two factors that would increase the rate at which the water evaporates from the puddle. I can do better than that. I can give 4, so any 4 of these would be acceptable. So we could increase the surface area of the water. That would work. We could increase the temperature of the water, so the particles have more energy. We could increase the wind speed, so it would decrease the humidity above the puddle, and we could decrease the humidity of the air, or reduce the amount of water contained in the air above the puddle. Any 4 of those would be absolutely fine. That's the answer. So we are now refueling the aircraft through a rubber pipe, and as the fuel flows through the rubber pipe, it becomes positively charged. Suggest in terms of electrons why the fuel becomes positively charged. So you should have seen an experiment where we use some kind of friction to leave objects charged. So what must be happening is friction is acting on the oil as it flows through the pipe, and if it's becoming positively charged, the friction is removing electrons, and that's why it's positively charged. Okay, so moving on to question 6, looking at waves, more specifically the electromagnetic spectrum. And we want to put visible light in the right place. So visible should be bang in the middle next to ultraviolet. Yep, that's where it goes. So gamma radiation is emitted from some unstable nuclei. Gamma radiation is ionizing. State one risk to humans of exposure to ionizing radiation. So the danger is the interaction of ionizing radiation and our DNA. And ionizing radiation can mutate or change our DNA. And if you get the wrong kinds of mutations, that can lead to you having cancer, which is what the real risk is. The alpha radiation is also emitted from some unstable nuclei. State one difference between gamma radiation and alpha radiation. So there's a few different ones you could go for, so any of these would be fine. Gamma radiation is less ionizing, or it causes fewer ionizations, I should say. Gamma radiation is neutral, whereas alpha particles have charge. Gamma is much more penetrating. It can go through thicker and denser materials. And gamma is a wave and alpha is a particle. Any of those would be absolutely fine. You only needed one. Okay, so moving on to some optics. So we've got light passing through an optical fiber, and it uses the principle of total internal reflection. There are two errors the student has made on this diagram. Identify where they are. So the first error is at this boundary here. When we have total internal reflection, that means all of the light has been reflected, whereas we can see some of it has been refracted at that boundary. So that can't be right. And the other problem is right at the end, you can see the light ray bending. So light ray cannot bend unless it's changing from one medium into another. So in an optical fiber, it's in glass the whole time, therefore it can only travel in straight lines because it's not crossing any boundaries. Okay, so the frequency of red light is 4 times 10 to the 14 hertz. The speed is 3 times 10 to the 8. Calculate the wavelength. So the formula we need is speed is equal to the wavelength times the frequency. We want the wavelength, so we're going to divide both sides by the frequency and then put the numbers in, and we end up with 7.5 times 10 to the minus 7 meters. Okay, so the frequency of blue light is 6.5 times 10 to the 14 hertz. Write down the speed of blue light in a vacuum, 3 times 10 to the 8 meters per second. The reason is all electromagnetic waves travel at 3 times 10 to the 8 meters per second in a vacuum. Doesn't matter if they're gamma, if they're radio, blue, red, whatever, they all travel at the same speed in a vacuum. Nice and straightforward. Okay. So we've got two objects, one is painted black, the other is painted white, and they're left outside on a hot, sunny day, so they're being bombarded with radiation from the sun. So that's the main form of energy transfer that we've got. Space is a vacuum, so the only kind of method of transmission is radiation. So state the process by which energy is released in the sun. So inside the sun, you have a process of nuclear fusion, where you're taking two hydrogen nuclei and fusing them together to form helium. The black car gets much hotter than the white car. Suggest why it gets hotter than the white car. Well, it's due to the fact that it is a better absorber of radiation. So black is a good absorber of radiation. White is very reflective for the type of radiation that we've got coming from the sun. Okay, so each of the cars has its own electrical generator to generate electricity for the car. Figure 8.2 shows a simple AC generator. Explain how the rotation of the coil in the magnetic field and the use of slip rings produce an alternating current. So there are essentially three key stages here. So the first thing is that the coil cuts through the magnetic field lines. So imagine the field lines going from north to south horizontally across the page. As the coil rotates, it cuts through those lines. Therefore, the coil experiences a changing magnetic field as it cuts through those lines. And whenever you get a changing magnetic field, an EMF is induced. And that EMF is going to be in a different direction every half turn, which is why we get an alternating current. And the reason we have those slip rings, which you can see right at the bottom of the diagram, is we need to be able to connect that into a circuit if we want to harness the generator. If we just had wires, they would get all tangled up as the wire spins. If we use slip rings, it makes it easier to connect into a circuit. Okay. So the engine in the car is noisy. It emits sound at a frequency of 5,000 hertz. State what is meant by the term frequency. So frequency is the number of waves per second traveling through a point, the number of waves per second. While he was driving, the driver noticed the noise from the engine becomes quieter and the frequency decreases. State whether the sound waves have a larger or smaller amplitude. Well, they have smaller because it's quieter. And they also have a lower pitch because there is a lower frequency or a smaller frequency. Sound waves produced travel through air by compressions and rarefactions. Describe the difference between a compression and a rarefaction. So a compression is where the medium density is slightly higher, so the particles of the medium have been compressed together, and a rarefaction is where the medium density will be slightly lower because the particles have been spread out at that point. Okay, so moving on to question 12. A torch contains 4 cells, a filament lamp and a switch, all connected in series. Draw a circuit diagram. So this is your circuit diagram. All the 4 cells are pointing in the same direction, so they add together. We've got our switch and then a light bulb. Okay, so the current in the lamp is 0.7 amps when it's at its normal brightness, and it's switched on for 20 minutes. Calculate the total charge that passes through in that time. So we're going to use Q equals IT. We've got the current and we've got the time. The time we need to convert into seconds, and there we get 840 coulombs. So 2 lamps, one resistance 4 ohms and one resistance 12 ohms are connected in parallel. Calculate the total resistance of the 2 lamps in parallel. So we're going to need the reciprocal rule, or the 1/over rule, for resistors in parallel. We plug the numbers in. So 1/4 is equal to 3/12. So we get 1 over the total is equal to 4/12. Therefore, the total equals 3 ohms. So a resistor of 3 ohms and a resistor of 10 ohms can be arranged in either series or in parallel and connected to a battery. Tick which of the statements are correct. So the current in each resistor is the same. Well, that will be when they're in series. Potential difference across each resistance is the same. That's when they're in parallel. Okay, so that finishes off this review of this particular exam. I hope you found that useful, and thank you very much for taking the time to watch.